To reveal why this is, we need to travel 2,000 kilometers south.
I am in the coastal state where the monsoon first arrives in India, Kerala. The key to understanding the monsoon is here, on the beach. The monsoon is powered by a simple but incredibly significant difference: the difference between land and sea. And in particular, the differing ways in which they respond to the sun.
Take the sand as an example. The sun's energy is heating all of this surface. But if I dig down just a little way, the sand underneath here is quite cool, and that's quite familiar. We see that on sunny beaches all the time. And here, where it gets really hot, the surface can reach 40 degrees Celsius. Just 15 centimeters down into the sand, it could be only 7 degrees Celsius. So all of the sun's energy is going into a really thin surface layer, and that layer heats up really, really quickly. The sun is also beating down on the ocean, and that responds very, very differently. This water is much warmer than the sea at home, but it's much cooler than the beach. And the reason for that is that the ocean takes much more of the sun's energy to heat it up. So a kilogram of water will take 3 times as much energy as a kilogram of sand to heat by 1 degree. The ocean is also relatively cool because to heat the surface, you have to heat much more than just a thin layer. What happens is that winds that blow across the surface of the ocean generate turbulence which mixes that top layer. So as soon as some water's been heated at the top, it gets mixed down below.
This means that, unlike the land, the ocean warms up only very slowly as the sun's energy is absorbed. So as we enter summer, the land heats up quickly while the ocean lags further and further behind. This increasing temperature difference is critical because both land and sea heat the air above them. As the sun has baked the Indian subcontinent, the land has warmed the air above it. The warmer air is less dense, so it rises. This draws in the cooler air from the ocean. Because of India's particular geography, this process is magnified. It's a triangular peninsula with wide, hot plains and, crucially, a very long coastline. This combination sets up a powerful and sustained movement of cooler ocean air, the monsoon wind.
Of course, when most of us think of a monsoon, we think not of seasonal winds, but of rain. By setting up a time-lapse camera, I'm hoping to watch the rain clouds forming. Process on the go here. When the sun shines down on the ocean surface, some of the water at the surface will evaporate, so water and energy are carried up into the atmosphere. And as the monsoon winds come inland and they carry that water vapour with them, the heated land makes that moist air rise, goes up into the clouds, and there droplets condense. The water condenses out, becomes visible, we see clouds, and when those droplets join together to form droplets that are large enough, we get rain like this, and it's really raining hard now. So what we're seeing now is a thin layer of the ocean that's been lifted up, shifted over here, and is now being dumped on top of me. None of this would be happening if it wasn't for the tilt of the Earth. The seasonal heating is what widens the gap in temperature between the land and the sea. And this drives everything, and this massive system of rain and wind rushes inland, and that's the monsoon. Wet, so drenched. I feel like I've been in a shower for about 10 minutes. I suppose I have.